Okay, good evening, everyone. Okay, let's start off for the day, guys. Let me give you my brief introduction. My name is Abhay Agarwal, and I have been in the IT industry for last 19 years. I started my career from Tata Teleservices in 2001 after doing BCA, MCA, and MBA from Nursing Monji. After doing job in Tata Teleservices, majorly into Unix shell scripting, I joined American Express, Gurgaon. I worked there for next 2 years, majorly into data warehousing tool like SAS, Ab initio, Hyperion, Sbase. Then I moved to GE Capital. I worked there for another 1 year, majorly into data warehousing tools as well as Python scripting. Then I moved to IBM. I worked there for 4 years, majorly into data science projects and artificial intelligence and machine learning. Then I moved to HSBC Bangalore HDPI department, that is for data processing unit. I worked in auto as an automation engineer and majorly worked on the automation projects pertaining to Python, machine learning with R as well. Then I moved to United Health Group. I worked there for rest of my career till 2010 as a data scientist. And from 2011 till now, I have been into IT industry for training and training and certification projects for different companies, for corporates as well as for online trainers. I've been associated with that Cognixia for almost like 3 years, and I've delivered more than 1,500 trainings in my IT career for the last 9 years in deep learning, machine learning, data science with Python, as well as R programming. I'm certified SAS professional. I'm certified Unix professional. I'm certified PMP professional, and I'm here for your growth in your career. Just to explain you what exactly machine learning is all about and how it is related to data science. We are going to talk in detail why it is really important in today's world to work on data science, primarily in machine learning and artificial intelligence. So just to give you a brief idea about Cognixia, Cognixia is an award-winning training arm of an Collabera. So Collabera is a parent company. Cognixia is a part which is working in India primarily. It has delivered trainings in more than 37 countries, and over 10 lakh professionals have been trained worldwide till now. More than 450 clients across the globe on which Cognixia has delivered trainings, and 4,500 plus trainers Cognixia has got. I am one of the trainers in Cognixia, and I've delivered almost like 100 batches for Cognixia for machine learning and data science. Best in class training for emerging technologies. So, what all technologies which are emerging in today's world, Cognixia has been delivering training for the long time. So, as I already told you, like Cognixia is an award-winning company. So you can see the number of awards Cognixia has got from the different areas, from Malaysia, from Mumbai, from IoT India magazine, from World Class HRD Congress, and it has got a leadership award for the Middle East from the Middle East after delivering training in the Africa Leadership Excellence. It has got awards for the Big Data Hadoop Developer for the year 2016, a Training Award Leadership Award for the Dubai, and for Silicon India for higher education, top five cloud training awards, top five big data training institutes by Silicon India in 2017, and continuously in 2017 again top 10 promising IoT training institutes in India. So these are the training partners which are there with Cognitia, Red Hat, MAPR, and PartnerWorks, Microsoft Partner, Pivotal, Dell, EMC Square, VMware, RSA, Automation Anywhere, ITIL, ISC Square. Now, what we are going to learn today, or what we are going to understand today, is why Python is more useful in machine learning field. What makes Python so popular? Why is it so that people are learning Python these days? And it has grown up like anything in the last 3 to 4 years. Why it is so? Why Python is so popular? We're going to talk about that. Major differences between Python and R programming. So many people have a question: why Python? Why not R? Or why R? Why not Python? So we'll talk about the differences between them. Going to talk about the industry trends in machine learning. Why people are going for machine learning these days, and how the industry is moving from the traditional programming to the machine learning programming. Career growth and opportunities we are going to talk about, like why it is important to learn machine learning so that you can grow in your career. What is a machine learning and what is data science? We are going to talk about that in detail. We are going to talk about why machine learning and data science in today's industry. We're going to talk about three types of learning, machine learning, that is supervised, unsupervised, and reinforcement learning. And we'll talk about the use cases of machine learning. So this session is going to end by 9 p.m. So I'll try to cover everything by 8:30 or 8:45 p.m. IST, and I'll keep 15 minutes for question and answers so that you can ask questions from me. As the number of candidates are quite high in this today's session, that is almost like 700 plus people have joined. So I'll be addressing the important questions which I feel like, okay, these are the relevant ones and I can answer them. So the ground rules for this agenda is that, like, please don't ping me on the chat window because I get distracted. So I can see many people are asking questions on the chat window. So it's really impossible to address all the queries, 700 people queries to address in 2 hours time. So there's a backend team, support@cognixia.com, where you can write down an email or you can ask the queries later on. So I'll address most of them, but in case it is left out, you can ask from the support team. And you can visit the Cognixia website and take a number from there and call the support team as well. So please don't ping it in the chat window. It's a request, and I'll move on with a smooth pace. Okay, so let's move on. So who are using Python these days? The question comes, who are the popular users of Python? The popular users of Python is YouTube. YouTube video sharing system is largely written in Python. And if you see the market leaders today, like who are the players, who are the market leaders in the IT industry today, are majorly the ones who have started working in Python 10 years back. So if you see the big companies like Google or YouTube or Dropbox or Yahoo or Microsoft, everybody has been started working on machine learning projects almost like 10 years back, and they have delivered good products. Like you might have seen Amazon Alexa is one of the best products, which is recognizing your voice and playing the song for you. So the market leaders who are using this Python for the last 10 years are like YouTube, Google makes extensive use of Python in the web search system. Dropbox uses for the storage service codes both in the server and the client side. Raspberry Pi is a single board computer, promotes Python as an educational language. BitTorrent is using for peer-to-peer file sharing. NASA is using for specific programming tasks. Similarly, NSA is using for cryptography and intelligence. Netflix is using for documentation role in Python or software infrastructure. So if you observe, most of the companies who have been using Python, most of the companies are using Python for the long time. I'm sorry, the slide was not getting changed. Just give me a moment, it will change. Okay, so most of the companies who are using Python for the quite a long time is YouTube, Google, Dropbox, Raspberry Pi, BitTorrent, NASA, NSA, and Netflix. So you can see most of the companies have been using Python for the long time. I think it is visible to all of you now. Okay, why Python in the field of machine learning? The question is, why is it so popular? Why Python is so popular in today's scenario? And we are going to talk about why it is really important that we should learn Python. The first and basic reason why should we learn Python is it's very simple and easy to learn. You can learn Python in a very short time because it's more like an English language. It is free and open source. Python is an example of FLOSS, free, libre, and open source software, which means you can freely distribute the copies of this software and modify it. So Python is very much easy to install. You can install Python in your MacBook. You can install Python in your Windows operating system, or it comes inbuilt in the Unix and the Linux operating system. So if you buy any Linux box or a Unix box or CentOS or Ubuntu or Solaris, HPUX, any kind of a flavor of a Unix, if you're talking about, it is open source. It comes as an inbuilt over there. The Python is why Python is in the field of machine learning. The answer again here is it's a very high level programming language. You don't have to really worry about declaration of the variable. So if you want to declare any variable in Python, you simply say a equal to 10, and you don't have to tell a is an integer type. If you want to declare any string, you don't have to tell, okay, string type. You just say b equal to some name, and it is going to store b as a string type. Suppose you want to store any complex number, you can store directly a complex number. So it's a very high programming level language. Garbage collection is not required in Python. Garbage collection means what? Freeing of the memory or releasing the memory. So if you might have worked in C programming anytime, you might have observed that you need to free the memory, because if you declare a lot of variables, the memory gets filled up. But Python, the garbage collection is automatic in nature. So if you have two variables, a equal to 10 and b equal to 10, then both the variables have a same memory address in Python. And how do you check that? We simply write type of A and type of B. Type function we use to check what type of variable it is. It is going to say it's an integer type or a character type, and ID of A, ID function in Python is going to tell you what is the memory address of the variable. So if your two variables are there which are having the same value, they contains the same memory address. It is very much portable. You can export your Python code from Linux machine to the Windows machine, from the FreeBSD to the Macintosh or Solaris. It is not dependent on any hardware or a software. You can directly send your code from one machine to another, and it is very much portable in nature. So the benefit of is that many people in the worldwide, they are working on Linux or Unix or Mac OS. So everybody is working on the different operating systems. And if you develop the code which is generalized one for every machine, then it is really important to really easy for everyone to manage. Obviously, the path variables and all those things we have to change, because in Unix environment we have a backward slash, but in Windows we have a forward slash in the path variables. So why Python in the field of machine learning? Again, the reason is that supports different programming paradigm. It supports object-oriented programming, which is really important in today's world, because object-oriented programming ensures security to us. So we have different type of variables, public, protected, and private variables in object-oriented programming, and you can declare any variable private type so that the end user will not be able to change it at any point of time. or you need to use only methods to invoke that private variable. So object-oriented programming, all the facilities like inheritance, encapsulation, abstraction, everything comes automatically in Python. But polymorphism is something which is implicit in Python. Polymorphism means if you use a plus symbol to add to integers, it will add it. But if you use the plus symbol to add to strings, again, it is going to add it. So let me show you one small demo of that. Then I'll move on with the rest of the part. So this is Python idle. Python idle is a tool which comes automatically when you install Python in the Windows machine or Mac OS. So this is just a graphical user interface where, or a command line interface in a graphical mode. It directly gives you some help when you import some libraries. So Python idle is really important to work on because it's something like a Unix prompt where you type any command and you directly get the output. And it is pretty handy to do some kind of a coding over here. If you want to execute single line of code, then you generally use Python idle. So if you want to quickly see the results, or if you want to see what exactly is the output of a particular command, then you use Python idle. For example, if I declare A equal to 10, B equal to 20, and would say type of A, it comes as an integer. We don't have to tell A is an integer or B is an integer. Similarly, type of B, if you write, you directly get integer. And if you say ID of A, it is going to tell the memory address, and ID of B, it is going to tell the memory address. And you can see both are same. Both are not same because B is 20. Let me make B as 10. And then if I say ID of A, you'll see it is now same as ID of B. You can see A and B have a same memory address. So when the values were different, the memory address were different. But when the values become same, it is going to save the memory. So it is not going to allocate two different locations for A and B. Directly it has. I was talking about polymorphism. Polymorphism is something which is implicit in Python. Suppose you say 10 plus 20, you get the answer as 30. And if you say India plus, or if you say India plus USA, you get India USA. So you can see the plus symbol is working like a concatenation. So plus symbol here is working like a concatenation. For numbers, it is again adding the number. For strings, it is adding the two strings by concatenating. And if you multiply some string, let's just multiply India, multiply by 3, you are going to get concatenation of the particular string. So you can, it is pretty handy to work on Python side. And that is what I was explaining. In Python, we don't have to really bother much about variable declaration. And it is very much easy to work on. So what makes Python so popular in today's world? Because of the improved programmers' productivity. So obviously, as a programmer, if you get some language which is very powerful and syntactically easy to learn, you can develop a lot of codes in a short time. Secondly, its extensive support of libraries. Python has got 65,000 libraries. Libraries are what? It's simply a header file. Like in C program, if you include on the top of the code stdio.h or conio.h or math.h, and directly use the functions defined in these libraries. In Python also, these libraries are there, which are going to be imported directly, and you can use these libraries for any kind of a use that you want. Suppose I import a math library in this. For example, I import a math library, which is an inbuilt library in Python, and I can simply say print or math.py is going to give me the pi value. So math.py is going to give me the pi value. Math.sqrt of 2 going to give me the square root value of 2. So these are the inbuilt libraries. There's so many external libraries which made Python really popular. And it has got 65,000 libraries pertaining to any area. If you go to pypi.org, pypi.org, there's a website, official website of Python called pypi.org, and you search any library, you'll get the library there, name of the library, and you can directly install in your machine by pip install that library name. And it has got 65,000 libraries. And imagine the area like aerodynamics, area like banking domain, area like telecommunication, area like automobile industry, any area, biometrics. These libraries are there, which is going to directly predict something for you or going to give some results to you. There's a library called NumPy. Why Python picked up? Because of the four major libraries or five major libraries: NumPy, Matplotlib, Pandas, Seaborn, sklearn. So sklearn is a library for machine learning. Majorly all the algorithms already present in sklearn. Cboard is for plotting some graphs. Pandas is for data exploration, data analytics, and exploration. Matplotlib is basically used for plotting graphs. Again, in Cbound, it's easy to plot some graph. In Matplotlib, the syntax is quite difficult. NumPy is for numerical analysis. So maybe a linear algebra or some polynomial equations or some kind of integration or differentiation problems. We can easily solve it through NumPy library. So these are the major 5 libraries because of which Python has picked up and people started using it and they found really easy to work on. So let me come back to the presentation. And that is the reason I've written over here. It's extensive support of libraries. Its integration feature is very great. So if you might have worked on Hadoop and Spark environment, which is again working on MapReduce framework, you might have observed that Hadoop systems and Spark systems are really faster in nature because they're working on distributed environment. What is Hadoop system? We have Hadoop server, which is connected to the nodes. Nodes are nothing but the clients or the computers, and there are hundreds of them connected parallelly. And if suppose 1 terabyte data comes, it divides the data into multiple nodes. They parallelly process it and send the results back to the server. And if you see the library called PySpark or PyDoop, they are having the integration with Hadoop and Spark environment. Similarly, you have a lot of libraries for integration with Java code or a C++ code or a PHP code. You can integrate Python with any programming language. It increases the productivity of the programmer, obviously. It is very much robust. You can pass on terabytes of data to Python to process, and it is going to process it very fast. Because of the program portability, you can export your program from one machine to another without major changes. And that is again because of which people are using Python. It is very much interactive, interpreted, and dynamic. So interpreted means execution of the code line by line. So Python is both a interpreted and a compiled environment. It is dynamic in nature. Depending on the input, the output changes. For example, I've shown you some strings. When you add two strings, the plus symbol is going to concatenate it. But when you use a plus symbol for numbers, it is going to add two numbers. So it depends on the input that changes this nature. It is very much object-oriented programming in nature, and that's the reason Python is really popular. So these are the areas because of which programmers really like Python. Now, if you see the job trends in Indeed.com, you'll see there's a remarkable increase in the Python in the last 4 years or 5 years. You can see the blue color line, which is the demand for Python, and it is really grown up and it is still growing up. So if you go to the Indeed.com and see the job trends and type in Python and as compared to the other languages, you'll see the Python coming on the top. Similarly, if you see the Google trends, you'll see Python has a remarkable increase from 2017 till now. If this number has been increased a lot. So last 2 years, the demand of Python is really high. So out of total jobs, 99 jobs are of Python, PHP 65, Scala 5, Ruby 11, and R is 36. Now the question comes, what is the difference between Python and R? So many people ask this question whether to study Python or whether to study R programming. So Python you can say as a king of data science programming languages. So Python is something which is really popular because it's a king of data science. You can do anything pertaining to data science, but R is a golden child of a data science. You can say the scope of R programming is not very huge. Majorly the companies who are into banking domain, they use R programming because they need some stats to work on. So people who are developing some software or end-to-end software, they use Python because Python has got everything for development. It has got its own database. You don't have to install any Oracle or SQL or MySQL, any kind of a RDBMS into your machine. Python can take care of everything because Python has got a library called SQLite3, which is used for RDBMS programming. So there's a library called SQLite3, which is used for RDBMS purpose. You can create your own tables, you can create your own schemas, you can join the tables, you can do any type of SQL queries that you have been working on. So that is the reason Python is really popular. From end-to-end programming, there is a framework called Django framework in Python. Django framework for web development. So you can create your websites and do end-to-end web development using Django framework. And that is the reason why Python is so popular. So you can see Python is a king of data science. You can perform all the data science activities in Python. We'll talk about what is data science. It is general purpose language which is known for simple syntax, compatibility with the different operating systems. So it is very much easy to install in any of the operating systems. R is also open source programming and very beneficial for statistical computing. So generally companies in the banking domain, on trade, they use Python R programming because they want some results statistically. They don't want end-to-end development. Their internal team is looking at those results and taking some decisions. Python is more popular because of its broadness. Like if you think Python as a Pacific Ocean, R is an Indian Ocean. So Python is a deep ocean which is very broad, efficient, extensible, can be mastered easily. But R is also an open source. It is again used as an analytical toolkit majorly. It is not for the development. So if you want to develop some front end, then you can't do it in R. But in Python, there's a library called tkinter, which is used for development of a front end. It is very much robust. R is robust programming language and is powerful package ecosystem. Python picked up the popularity because of the major libraries like NumPy, SciPy, Matplotlib, and Pandas. SciPy is for scientific analysis. NumPy, Matplotlib, and Pandas I already told you for numerical analysis, for plotting graphs, for data exploration. Then carrots, string gr, and ggplot2 is used in R again for plotting graphs or for string operations. Popular applications which are made up in Python are Dropbox is written in Python programming language, which is now close to 170 million users. Various plugins are in Python are created in Python. So various plugins you might have seen and the different softwares are made by Python. RS program is widely used in the industry, which use data-driven decision support and statistical data analysis. So when you are looking for stats results, like you want to find out the linear relation between the variables, or you want to find out how the logistic regression works, what is a p-value, what is r square value, what is mean, what is standard deviation, what is covariance, then generally we use R programming and it is faster in nature. Zillows use R programming to promote prices. So few of the companies are using for decision making. Now, if you talk about the evolution of the machines have evolved in the last 50 years a lot. So you might have seen, I still remember in my school days when I was in 12th standard, I used to carry my floppy disk, and floppy disk has got only 1.44 MB memory. And even if small humidity is going to destroy that floppy, the life of floppy is very bad. Like even if you plug in that floppy drive for 2 times, third time you will not be able to read the data. And the capacity you can think of 1.44 MB. Then comes CD drives, then come DVD, then come pen drives. And now you can see the prices of these pen drives are really very, very economical. Previously, you used to spend more than 2,000 bucks to get a pen drive. Now you get the same in 500 rupees or 200 bucks. So evolution is there in the industry, both in hardware and the software. So if you see the evolution, artificial intelligence has evolved from 1950 to 1970s. It came into existence. The idea of artificial intelligence came into existence, and the term AI is coined in 1956. So it's a very old technology. Many of you who are graduated from the computer science background, you might have learned a subject called automata. Automata is one of the toughest subjects in the BTech or MCS in many colleges, where we talk about artificial intelligence, where we talk about context-free grammar. So context-free grammar in today's world is used by natural language processing. There is something called NLP, which is a very popular domain in today's world, where you want to make your machine interact with you by voice. That is human language understanding. That is natural language processing. So artificial intelligence is a quite older field, but it picked up its popularity because now we have a tools to work on this. Although people know it theoretically, although people were working on it by writing long programs, but those are not very efficient because those programs are going to break if your data is going to be very huge. Now we have a programming language Python which has got a inbuilt libraries for artificial intelligence. There's a library in Python called NLTK, which is used for natural language processing. And this library is pretty handy in nature for understanding the words what we are saying. So what do you mean by natural language processing? NLP simply means when you're talking to Alexa device or Google Dot, they understand the context behind it. What do you mean by context? Suppose you are commanding something, you are asking something, you are requesting something, you are telling something. There's a difference. So the way we talk, if the machine understands what we want and understand the context behind it, those are the smart machines. Like Alexa and Google Dot are doing the same thing. And again, they are getting matured day by day. It's not like this, they are pre-feeded with your voice. So I recently bought Alexa around 6 months back, and I was really disappointed in getting that device. Why? Because of two reasons. It's a home device. If I am traveling in my car, I cannot take Alexa along with me. Secondly, when I talk to Alexa initially for 1 day or 2 days, it was not playing whatever I was asking it to play, or it was not giving me the exact answers what I was looking for. Then slowly and gradually I keep on talking to the device, and the time has come when this device becomes smarter. Now, even if I whisper in front of the device understands what I want to say, because it understands my accent, it understands what I mean to say, it completely understands, and that is known as the reinforcement learning. We'll talk about that in detail, where the systems get mature slowly and gradually by understanding the patterns or the voice or the data we are supplying to the machine. They become smarter. And NLTK is a popular field in today's world. Everybody is looking for voice-based recognition, and this is the popular area where you can work on data science. Now, coming back to the presentation, artificial intelligence came in 1950s. Then what happens within the internet in a minute? So why data science is required? The answer comes here. So you can see there are 204 million emails sent in a minute. 20 new victims are identified for theft. 47,000 apps get downloaded. 61,141 hours of music people are listening. 20 million photo views are there in every minute. 100,000 new tweets. 320 plus new Twitter accounts. 2 million plus searches. 30 hours of video uploaded, or more than lakhs or 6 million logins in a Facebook every minute. You can see the amount of data on the internet which is flowing in today's world, or the servers who are carrying this data, is tremendous. You can think of petabytes of data which is flowing on the daily basis. And in order to deal with this huge amount of data, we need some smarter technologies. Hardware, it is not possible to manage everything. So you might have seen around 10 years back or 8 years back, mainframes were very popular. Every company used to work on mainframes. I personally worked on mainframes in initial career for 5 years. Now you can see mainframes are nowhere. Majorly people are working on the free open source systems like Hadoop and Spark. So the technology like Hadoop and Spark has overcome the drawbacks of hardware dependency. And with the Hadoop cluster, you can join with thousands of nodes together. And as soon as the data comes, which is of 1 terabyte, it is going to divide this into smaller parts called mapping, sending it to different nodes, getting it processed, getting the results back called reducing, and sending the results to the end user. Now, Amazon Web Services, again, a very popular example. You might have worked on AWS. It's again a very good technology. Companies who cannot afford servers of millions of dollars, they go to AWS and take the server on the rental basis, and they work on that in a very easy basis. Now, because of the terabytes of data, or you can say petabytes of data, this new technologies have evolved. And why they become more popular? Because of the cost effectiveness. Amazon provides you the service free of cost, almost with 1 rupee, if you want to open an account in Amazon. From the next year, they're going to charge on the rental basis, depending on the type of services you are looking for. So many programming languages got obsolete. Now you might have heard about SAS programming language. I personally worked on SAS for 7 years, and now you can see companies are switching from SAS to Python or R programming. Why? Because SAS desktop license, I still remember in 2009, was 3 lakh rupees per desktop. Now, in order to procure the software, company used to spend huge amount of money. And now in today's world, people are looking for the cost effective methods where people can get the leverage of the software or hardware in a minimum cost. And that's the reason Hadoop and Spark environment becomes popular. And Python is very much popular in Hadoop and Spark environment because it can work easily. Now, what is the confusion between data science, AI, ML, and deep learning? These terms have been quite frequently used by many people. Let me tell you what is the difference. So data science is a bigger domain. In data science, all the fields comes. All the fields like natural language processing, artificial intelligence, data analytics. So data science contains data analytics, predictive analysis, any kind of a job which you are playing around with the data comes in the data science, which involves a lot of fields like robotics, like artificial intelligence, like machine learning, like deep learning, all other subsets of data science. So data science is a bigger domain. In whatever the field you're talking about, data science is the bigger domain which carries artificial intelligence as a subset. So artificial intelligence is a subset of data science, and artificial intelligence contains the areas where system we are generating the intelligence, a technique which enables machine to mimic human behavior. So anything which we see like that, like Alexa device, like a robotics, like a IoT technology. IoT is what? Internet of Things. Where when you talk in front of a car that I want to reach this place, car will show it on the GPS. Like the Ola cabs, like the Uber cabs. So artificial intelligence is a bigger domain which contains many subfields like robotics, like natural language processing, like biometrics, and everywhere you are seeing they're mimicking like a human behavior. Now, machine learning is a subset of artificial intelligence, and it is all about predictive analysis. Machine learning is nothing but a predictive analysis. So if I write down, machine learning is a subset of artificial intelligence, and it is all about predictive analysis. Now, what do you mean predictive analysis? Like you might be looking at in today's scenario, or maybe in older times, we used to go to astrologer, right? Astrologer is doing what? You go to astrologer saying that my job is not going good. Tell me what to do. The astrologer is going to tell you some stones to wear, or is going to give you some tricks and tracks to do this, and you do that things. And if time comes later on, you find that the predictions are right, you are going to rely on that astrologer, and you again go there. And if you find the predictions are not right, then you leave that astrologer. Now, question comes, when your astrologer is predicting your future, how much accurate he is? We don't know. We're just relying on him. We don't know whether he's 80% accurate, 90% accurate, or 100% accurate. But when you talk about science, science do not believe in assumptions. Science believe in some proofs or some kind of results which are going to verify that predictions. So data science in machine learning, we do predictive analysis and we find the accuracy, how much accurate we are in predictions. So in machine learning, we find or we predict future and tell to end user that in prediction we are X% accurate. Like for example, if I give you the historical data of rainfall, humidity, and crop yield for the last 20 years, and if I'll ask you what is the crop yield in 2019, then you can predict it. And when you predict it, you are going to say my accuracy is 90% in prediction. So I'm going to rely on that algorithm, which is predicting for me, and I'm going to use it again and again. Now, the prediction word is something which is very abstract. When you're talking about the human lives, when you're talking about the aeronautical industry, if I say the aeroplane is going to land safely, the accuracy is 90%, you will not board that plane. There's a 10% risk involved. So when the human lives are involved, the accuracy term has a different meaning altogether, which people rely when the accuracy is 100% for the model for prediction. But when you're trying to open a Pizza Hut in the nearby place and you say the accuracy is 75% that Pizza Hut is going to work well, then you rely on that. You rely and say, okay, I'll open the Pizza Hut. So that is all about machine learning, which is doing predictive analysis, and we do predictions and find out the accuracy of the predictions. Now, this finding the accuracy of the predictions is also known as cross-validation. Cross-validation techniques, and many techniques are there. There is something called look-off technique. There is something called k-fold cross-validation. So they are basically inbuilt algorithms. There is a k-fold cross-validation. There are many techniques of validating whether the results you are getting is good or bad. And you don't have to reinvent the wheel. All these algorithms are inbuilt in Python. You don't have to write down the code from scratch. You just need to import a sklearn library and import k-fold and directly supply the data to the k-fold algorithm, and k-fold is going to run the algorithm multiple times internally and finding the average of all the accuracies. So once you take the course Python, you come to know all these techniques very easy. So I was talking about machine learning. Machine learning is just a subset of artificial intelligence, and it is all about predictive analysis. Deep learning is a subset of machine learning which makes computation of multi-layer neural networks. Now, what is deep learning? In the layman terms, I'll explain you. Let's say you are working in a telecom company and you have a 5,000 fields about different areas. You have a big table which is stored in Oracle or DBMS, and you have a 5,000 fields, and you want to do some predictive analysis. So fields, or you want to do predictive analysis, how much the bill customer is going to have in next month. So you have thousands of customers who are there with the company for last 10 years, and you want to predict their bills in the upcoming months. Now you don't want the KYC details over there. You don't want their name, you don't want their address, you don't want their location, you don't want their kind of salaries or any kind of personal details. What do you want? You want the calling details. So what you will do, you will filter out the records or columns from the table which are of interest to you. You will not feed in the whole data to the algorithm, maybe linear regression. You will filter out the data which is of interest to you and then supply it to the algorithm. What you are doing? you are manually doing feature extraction. You are finding out what features means columns, are important to you. In deep learning, this drawback is not there. It's not a job of a data scientist to pick up the columns of interest. He will feed in the data completely blindly to these algorithms of deep learning, and deep learning algorithms are going to find out how the independent and dependent variables are related to each other and do the mapping using neural networks. So that is the biggest difference between machine learning and deep learning. The feature extraction is automatic in deep learning, and that makes a data analyst or data scientist role is really easy. And deep learning is again a black box. Google has made these deep learning algorithms, and they shared with us as an open source. But still, the research is going on. It's not a completely mature field. It's something which is still growing, and Google has not disclosed the algorithms behind it. They does disclose the names and some parts of it, how it is working, but not statistically how it is working. Google has not declared. So deep learning algorithms are those which are generally used for complex problems like image recognition, like biometrics, like eye retina scan, like computer vision, all these areas which are quite complex where data is in multiple dimensions. We use deep learning algorithms. So is there any overlap between machine learning and data science? So let's talk about that. Because data science is a broad term for multiple disciplines, machine learning fits with data science. So data science is a broader term. Machine learning is just a subset of it. Machine learning uses various techniques like regression and supervised clustering. On the other hand, data in data science may or may not evolve for the machine or mechanical processes. So you may be having a data, but you cannot feed the data into machine learning algorithm because machine learning algorithm looks for independent and dependent variables or maybe unsupervised data where we do not know the data completely. But data may not be that much mature that you feed into the machine learning algorithm. So the main difference between the two is that data science is a broader term, not only focuses on algorithms and statistics, but also takes care of entire data processing methodology. So if you see data science multidisciplinary approach, where you can do statistics, where you can do pattern recognition, where you can neurocomputing, you can do databases processing, data mining, artificial intelligence, business strategy, domain knowledge, all these things when you combine together, it becomes a data science. Like in science, we have a different sub areas like physics, chemistry, and biology, right? And all together is known as a data science. Here also, data science is a multidisciplinary approach where all the technologies, all the areas like stats, pattern recognition, visualization, data mining, all are combined together, and we call it as a data science. So it's a bigger domain. It's not only about algorithms that we use in machine learning. So if you see data science method, first of all, we formulate a question, then we gather the data, then we analyze it, and finally we get the product. So this is a basic flow in any kind of a problem. First of all, we have a question in front of us. Then we gather the data to solve that question. Then we analyze it completely, how exactly our results are. And once the answers are satisfactory to us, we deploy it on the server. So that is a basic data science methodology we generally use in real life. Now there are two approaches of data science. One is called top-down, one is called bottom-up. Top-down approach means you have a business problem, you have a domain, then after looking at the business problem, you have a domain knowledge, then you collect the information particular to that domain and finally come to the facts and figures. Or you may have some data there in hand, but you don't know what this data is. You fetch the information about the data, what data it is, then you map it with the domain knowledge that you already have, and then you give solving approach, or you give some algorithms for problem solving. So there can be a top-down approach where you are starting from the business problem and getting the facts, or you may have some raw data and you're coming to the algorithms or the facts out of it. That are two approaches in data science. One is called top-down and the is called bottom-up. Now, if you see machine learning potentials across the industry, so if you see the bigger circle means the bigger aspect. You can see the bigger circle. The bigger circle means it has a more impact. The smaller circle means it has a lesser impact. So that is the impact score. On the x-axis, you see the impact score, and on the y-axis, you see the volume. So we can see agriculture industry, although it is not very mature, it has got a low impact. It has got a low impact, and the volume people are using for agriculture industry is very low. The green color circles. If you see the dark blue circle, that is media. You see the media, this is having a very high impact and very high volume of data which is using, like Facebook, like Twitter, like Amazon. All these are dealing with marketing and promotions. They're using artificial intelligence or machine learning very heavily. Similarly, in telecom domain, you might have seen the light blue color circle is very predominantly people are using. Similarly, healthcare, you can see companies are using very frequently. For the people who are having less priority, that may be in agriculture, maybe in automotive industry, maybe in energy, people are not very frequently used, but generally people are generally using it for personalized advertising, identify and navigate roads, optimize pricing, predict personalized health conditions, discover new customer trends, optimizing merchandise strategy, predictive analysis in the energy, fraudulent transactions, personalized financial products. So all these areas, machine learning is very popularly used, and that's the reason it is very much in demand. So this is another very good example which is showing impact potential from low to high. So if you see real-time optimizations, the dark color circles means high impact. So if you want to optimize real-time problems in automotive industry, manufacturing, consumer, agriculture, energy, you'll see the high impact. Similarly, strategic optimization, again, I have automotive industry, manufacturing, consumer, finance, agriculture, energy, or every company is using it for strategic optimization. What do you mean by strategic optimization? Looking for the future and devising some strategy that my sale is going to be increased by next quarter. What should I do now? That is strategic optimization. Predictive analysis, you can see almost every company is using. And automotive industry is still in progress because you can see manless car research work is going on. It is not mature enough. So you have not seen any manless car in India or abroad as of now. Very few examples you have. Predictive maintenance, similarly, radical personalization, discover new trends, forecasting, all these areas you can see mostly this whole table is all about high impact, where every company is using it for different reasons. Now, if you see Netflix is one of the best examples which is using machine learning for recommendation engine. Engine means recommending some movies to you. Suppose I am a person who watch always thriller movie, then system is always going to recommend me some thriller movies based on my likings. System is going to do what? System is going to figure it out people who are the same taste as of mine, what they watched and how they rated. Based on that, system is going to give me recommendation of the same, and that is done by Netflix, recommending some movies to you based on your personalized taste. Similarly, Facebook is using quite frequently. Facebook is using for tagging the face of a person. So you might have observed when you move a mouse or move a cursor to the face, the automatic name comes out of it and you can tag it. So that face recognition, internal representation of the face system is understanding by comparing millions of faces and finding the names associated with it. This is very popular in Facebook tags. Another example I told is Alexa device. When you speak in front of Alexa, Alexa understands whether to switch on a bulb or whether to go for a cab, book a cab for you, or whether you want to have some food, order a food for you, or whether you want to play some music. So there's a very smart device which are learning slowly and gradually and coming to the global optimum where it understands everything. Similarly, spam mail filtering, whether the mail is spam or not, you can filter out using machine learning. You can pick up the softwares are internally automatically picking up based on some keywords like lottery or like or kind of a free gift. It is picking up and filtering out which mail is spam and which mail is not spam. Now, machine learning is the future of industry, which is demand for today and more than 2 million jobs globally by the end of 2019. And that is the reason I always say to the people that if you really want to stay in the IT industry for a longer period of time, better to learn Python. Leave everything, learn Python. That is the first step. Second step, learn Hadoop and Spark ecosystem. And third step is learn any RDBMS, maybe Oracle or Sybase or MySQL. If you learn these three things, definitely your career is going to be very much escalating one. You don't have to rely on any other softwares. So machine learning is the future of the industry. It is not mature. Mature in the terms like companies are opting it, they are going for it. They don't have a mature products there with us as of now. It's a demand for today. There's a huge demand for professionals like you to join these companies and work as a data scientist. And more than 2 million jobs globally by the end of 2019 you can think of coming to you, and you can opt for the kind of role what you want to play. So let me address two or three questions and then I'll move on with the presentation. Any questions from anyone, guys? So let me lower the hand first. Yeah, Shubham, this session is recorded. Okay, so kindly raise your hand if you have any doubts up till now. I'll address two, three queries and then I'll move on. So Harish is asking when will you get the certificate? After completion of the course from Cognixia, you'll get the certificate. Yeah, Ankit, IoT is a part of data science, definitely. Rashmi is asking, is Python going to replace Java? So no, Rashmi, it is not going to replace. The companies who are using Java for a longer time, their legacy codes are in Java, they will not come to Python. So all the companies who have a legacy codes, this it's just a rework for them. So they'll not shift it. No, I mean, Ash, Java cannot be used for machine learning. So Satish is asking question how to minimize the prediction error. So you have different matrices of finding out the accuracies. If the error is going to be high, definitely you need to switch on to a different model altogether. You need to drop that model and switch on to the model. There are different techniques like model boosting. There's an algorithm in Python called ADA boost, which is helping to boost up the accuracy of the particular model. So how to start machine learning? Anjali is asking, you can Start machine learning by taking a course from Cognixia, or you can learn from your own from the basics by getting some books of Python, and then then the next step is to learn statistics, because machine learning is all about stats. So you need to learn statistics on your own, and then you can become a data scientist, because stats is an essential part for machine learning. Somebody is asking why you're using Windows OS and not Linux. I have a Linux virtual machine there with me. That's the reason I'm using Windows. RDBMS is compulsory. No, it's not compulsory to become a data scientist. But yes, you should know some basic SQL. Yeah, definitely, Satish, you can learn Python without knowing Java. There is no need of learning Java. Python is an independent programming language, so you don't have to learn Java. So let me talk to somebody. I've got a ocean of questions over here. Yes, Jigar.
Are you able to hear me now?
Yes, I can hear you.
So I want to know that I'm a front-end developer, and how can I take leverages of front-end development technologies like JavaScript, HTML, in CSS, and all these technologies in this machine learning and Python?
See, there are libraries in Python which are generally used for text processing, so or for image recognition. Let's say you are having some document which is handwritten, okay, and you want to train your machine that if the next document you are going to supply to that machine, system understand how you have written A, B, C, D, or all the alphabets, and you want to train that machine. It is going to make your life very easy. Suppose you have got a bunch of documents which are handwritten, and you want to train your machine to learn from those documents and understand it. Then you can write on the machine learning code which is going to understand this text or image, and map it to the alphabets what you're looking for, and directly converting all the images to the Word documents. So this is a small example which is given for the content writing specific area, where you can train your machine to understand the handwritten docs and convert to a directly MS Word docs or any kind of a text docs. Getting my point?
No, actually, my question was that I'm comfortable with front-end technologies like HTML, JavaScript, and jQuery, AngularJS, Angular,
Okay.
React.
Okay.
So, what are the leverages I can take to learn the Python, or is it completely correlevant? I just want to ask that.
Is it completely what?
Correlation.
Okay, you want to find out how it is correlated. So Python, you can develop three technologies. You can start up development of the backend technologies. You can start up with the development of the middleware technologies or the front end technologies. So in Python, there's a tkinter library which you can use it for front end development. Any kind of a job that you can do with the Java or CSS, you can directly do it with Python. The libraries are there which helps us to create those front end very easily, right? Although this can
Yeah,
be done
okay,
in
got it.
Java and other programming languages, but Python, the syntactically you'll find it very easy, and the libraries that I'm telling you take inter, if you just look into it, you'll find functions are really easy to work on to create the front end areas.
Yeah, got it. Thank you.
Yeah, Jayesh, you are self muted.
Yeah, am I audible now?
Yes, I can hear you.
Yeah, so for example, when we in Python, like you have mentioned that they all the bigger companies are using it from past to 10 to 15 years. So for
Hmm.
example, if I have an experience around 3 or 4 years. So if I start learning today, and if I switch my job, like if my I will switch my allocations from normal development, like for example Java developer or somewhere, to the
Hmm.
Python. So how much at an average it will take time to learn and understand, like at average time frame?
For learning Python and machine learning,
Yeah.
so I would say whatever the classes you are going to take, suppose you're going to take an online class, whatever time as an instructor I give to the candidates, I ask them to give them three times more hours. So this generally batches of 48 hours. And if you are going to give
Okay.
more than 120 hours or 130 hours of self-learning, you'll become expert in
Okay.
short time. So generally it takes, on an average, people takes not more than 2 months to become expert in machine learning and with Python or data science with Python. If you are spending good amount of time of self-learning, if you are spending 5 hours a week on the daily basis,
Okay.
and on the weekends three
Okay.
hours, I would say you will take not more than 2 months.
Yeah, sure. Thank you. And can we have the access of your presentation, what you have shared?
Yeah, the recordings are available. You're going to have the emails having all the recordings.
Yeah, sure. Thank you for that.
Yeah, one more last question, guys, and then I'll move on with the presentation. Let me pick up randomly because there are 725 people in this room. So let me pick up any random name. So Himanshu, your mic is not there. Jasmeet, you are connected via web. That's the reason I'm not able to unmute you. You're self-muted from your side. Jasmeet, you are self-muted. Kindly unmute from your end.
Hi, this is just me here. Am I audible now?
Yes, I can hear you.
Yeah, actually, I'm working as a network engineer from past 6 years. So I wanted to learn Python so that I can create automation scripts for day-to-day networking things.
Mm.
So, like, is there something different course or something like that that I need to learn to get into it? Because I think we to create a Python script for net that connects to the network devices, there's some different library in the Python.
Right, right. So pertaining to any domain, you have a different libraries, but those library you will understand it very quickly. They are not very complex ones. The basic idea is that how the program of Python works. What are the different data structures like list, tuple, dictionaries, where you those are the containers of the data, or how object-oriented programming is done in Python, how the regular expression things can be done in Python, because in networking, regular expressions are quite frequently used. So
Mm-hmm.
your intention should be to learn Python first from deep, taking a deep dive in Python, understanding everything about Python, how it exactly works, what are the different data
Okay.
structures in it, how exactly it works, and then you look for a specific library pertaining to your domain in networking, maybe a beautiful soup or maybe a scrappy or maybe a request library, and take a deep dive in
Mm-hmm.
those libraries. It's something like you need to have a generalized knowledge. Like in MBBS, what we do, we learn all the subjects: anatomy, gynecology, physiotherapy, everything we learn, right? And
Mm-hmm.
then we become specialized in one domain, that is neurology. So that's the same thing. Python is a bigger domain. You need to learn everything first pertaining to Python. What is Django? Some brief introduction of it. What is data science? How machine learning code works? What is deep learning? And then pertaining to your networking skills, you can pick up those any library 3 or 4 and take a deep dive into that. You'll become expert
Okay.
in it.
So just wanted to know that those explanation of those libraries will be included in the course that will be given
No,
by
that is not
Cognixia.
that in Cognitia. This networking course is not there. Networking modules are not there, but definitely
Okay.
the instructor is going to talk about that. If you raise a concern and say, I want some networking modules to be explained to me, definitely the instructor
Okay.
will spend half an hour and give you some idea about these libraries and you can learn more about it. Or backend team can send you some documentation for the same. If you ask the backend team that I need help in this
Mhm.
domain, then definitely
Okay.
there is a dedicated team which is going to send a documentation to you.
Okay. Okay. Thank you so much.
Yep. In the meantime, you can type in your query in the chat window and I'll ask backend team address your queries on the chat itself. And before the end of the session, also, I'll take some more time to address your queries. So really, it's not possible to talk to everyone because of limitation of time, but I'll try to address as many queries as I can. So just ping in your chat queries on the chat window. The backend team is going to address that. So the question comes, what is machine learning? So machine learning is nothing. Machine learning is a subset of artificial intelligence. As I discussed, it's a subset of artificial intelligence which provides system the capability to learn on its. Now, as the definition says, machine learning is a subset of artificial intelligence which provides systems of machines the ability to learn automatically with and improve from experience without being explicitly programmed. Now, without being explicitly programmed, what do you mean by this? So, machine learning is a subset of artificial intelligence. We already seen that, and it is all about predictive analysis. Let's say you create a program which is writing down some algorithm, which is doing some predictive analysis about the crop yield of the last 30 years. Based on that, it is predicting something. Now you don't have to change the code. You just need to add on the data to it to make it more mature. So, the few prerequisites are there for machine learning. I'll just write it down. So, for machine learning, we should have first prerequisite is that we should have historical data which is proven, research based, accurate, so that predictions will be accurate. So if your data is not going to be accurate, obviously the predictions which you are making is not going to be accurate. So what you want the data has to be really accurate so that your predictions, what you're doing, is going to be accurate. Second prerequisite is that the larger the data you have, better the predictions are. Third is that you should be able to identify the independent and dependent variables in a data set. You should know what are the columns which are resulting into the dependent variable. For example, humidity, rainfall, and temperature are the important columns for the prediction of crop yield, right? But if I'll take humidity, rainfall, temperature, and the farmer's age, so farmer age is not important column. Farmer age is something which you can drop because it is crop yield is barely dependent on the farmer age. So the feature extraction is a responsibility of a data scientist in machine learning, and that is a prerequisite. And it is self-learning algorithm Why it is saying self-learning? Because once you create a code, you just need to add on more and more data to it, and the same algorithm is going to learn from the new and new data which is coming. It is finding the mapping between the independent dependent variables, and that is known as a linear regression, where you're finding the relation between independent and dependent variables. Now I'll explain you how exactly it happens. Let me open Excel sheet. So I'll tell you how exactly machine learning works. Just open the Excel sheet. Let me open it from here. Let me do one thing. It's taking more time. Let me use paper and pen. Okay. So what I'll do, let's say we have a data set. We have certain columns in that. So I'm going to explain you how machine learning algorithm works. Internal representation. Suppose we have a columns here. This is rainfall, humidity, temperature, and crop yield. So here we have three independent variables. These are the three independent variables, and we have a single dependent variable called crop yield. So in machine learning terminology, independent variables are also known as a data. So whenever you see the word in machine learning terminology, it is known as a data and it is known as a target. Dependent variable is known as a target, right? Now we have three independent variables: rainfall, humidity, and temperature. That is known as a data, and we have a dependent variable called target, that is crop yield. Now we are going to divide this data into four parts. So the first part of independent variables, we call it as a train X. The second part, the dependent variable, we call as a train Y. Last part is known as test X, and this part we call it as test Y. So what we did, we have divided the data into four parts, and the first part is known as a train X of independent variables, and the dependent variable is known as a train Y. The independent variables is known as a train X, and the dependent variable is known as a test X and test Y. So we divide the data into four parts. The first part is known as train, and the second part is known as a test. Now what we do, we use a sklearn library and import algorithm called linear regression. And in linear regression, we fit in train X and train Y. And once the model is ready, when we feed in this data of train X and train Y, the model becomes ready. And once the model is ready, we use lr.predict, linear regression.predict, and we pass in test X, independent variables of the same data set of the historical data. So this whole data is a historical data. So once we predict it, we get a new column here, that is predictions. Then we are going to compare test Y with the predicted values. So once we compare test Y with the predicted values, we can come to know the accuracy of the particular model. So what we did in this whole scenario, we take the independent variables and take a 75% data or maybe 80% data and call it as a train X. Then we take a dependent variable and call it as a train Y. Then we take the independent variable test X, that is 25%, and test Y as a 25% of the dependent variable. We create a model using training data set, train X and train Y. System is internally going to map the relationship between them. System is going to tell how they are related to each other. It is going to create a straight line, finding the relation between them in a form of equation called Y equal to mx plus c. System is going to create an internal equation and going to result into intercept and the slopes, how they are related to each other, how the independent variables are related to the dependent variable. System is going to figure it out for you. And once it is able to figure it out, you use the same model to predict the future. And once prediction is done, you can compare with the actual data, actual historical data, that is test Y. And we can say the accuracy of the model is something. So in linear regression, we have certain matrices for finding the accuracies, like mean squared error or mean absolute error or root mean squared error. So depending on the algorithm, we have accuracy. So this is a gist of machine learning. In all the algorithms of machine learning, let it be naive-bayes classifier or decision tree classifier or random forest or support vector machine, any kind of algorithm that you see across in machine learning that is using this method of training and testing data set. So there is an inbuilt library which is going to create these four parts. You don't have to manually do it. There's a library in Python which is internally going to do it automatically. So we talked about what is machine learning. Machine learning is something which is doing some predictive analysis for us. So there are three types of machine learning. Basically, one is called supervised learning, one is another is called unsupervised learning, and third is called as a reinforcement learning. So the first type of learning is known as supervised learning. Supervised learning is where you have input variables and the output variables, and you see the algorithm that is going to map the relation between the input and the output variables. So in supervised learning, we have the column headings there with us. In supervised learning, we have a column headings there with us, and we know the data completely, like the historical data for rainfall, humidity, and the crop yield, or the historical data of transactions made by the particular customer in the bank, or maybe stock prices with the dates. So when you know the column headings, that is known as supervised learning. And there are various supervised learning algorithms like linear regression, logistic regression, decision tree classifier, naive-bayes classifier. They are all supervised learning algorithms, which helps us to understand the data mapping between the independent and dependent variables. So it is a supervised learning because the process of algorithm learning from the training data set can be thought as a teacher supervising the learning process. Second type of algorithm is known as unsupervised learning. So we'll talk about that. In supervised learning, let's say you supply the data of a duck and not a duck, system is going to find a predictive model which is going to take a future input data and predict whether it's a duck or not a duck. So whenever the new input comes to the algorithm is going to accurately predict whether it's a duck or not a duck. Now, supervised learning use cases and the examples we want to see. One of the example is document classifier. Because we know what type of document it is, system can easily classify it. So any type of a document, maybe a PDF document or a text file or maybe a doc file or Excel file, it is going to easily classify it. Another example is a weather prediction. So we know the historical data of a days or particular date, what was the weather, what was the temperature of the particular day. And based on that, we can do the predictive analysis, what is going to be the weather tomorrow, or what is going to be the weather after 3 days or 4 days. So based on the historical data, we can predict the future of the particular weather, particular city weather. Then fingerprint analysis. Fingerprint is again a supervised learning data which is having some fingerprints in it. So fingerprints are something which we know, like how it is made. So how, what is the input, what is the output? So our input is something fingerprint and output is something which is mapped into a 0 and 1 formats. So it is going to store like a vectors or the images inside the mobile phone. So like a biometric mobile phone is going to understand whether your fingerprint is same or not for unlocking. So these are the few examples of supervised learning algorithms: linear regression, logistic regression, decision tree, random forest. So these are the few examples of supervised learning algorithms. So if you enroll for this course, we are going to talk about that in detail. We are going to take a deep dive into this and understand what are the different regression techniques, how decision tree classifier is there. There are different ways of finding decision tree, like there's something called Gini index or information gain to decide what node has to be the first decision taker. And random forest, we have a inbuilt variables called important variables, which is going to tell you what all columns are resultant into the dependent variable, why it is important. Similarly, naive-bayes classifier is something like a conditional probability. If something happens, what other happens? If suppose today we see the cloudy days, what is the probability of rain? So it is a conditional probability. We are going to solve it using machine learning algorithm. So all these algorithms are inbuilt in Python. You don't have to reinvent the wheel. You don't have to write down any code from the scratch. You just need to import this library and call these functions, and they take care of everything. Now, unsupervised learning is a training of model using information that is neither classified or labeled. Unsupervised learning is also known as a clustering analysis. I'll take a real-time example. Let's say an archaeologist find a bone deep inside the earth. How will you figure it out whose bone is this? What he'll do? He will find the color of the bone, he will find the texture of the bone, he will find the shape of the bone, weight of the bone, and then he's going to compare it with the historical data that is there in the museums. And then he's going to figure it out. Okay, this bone belongs to a dinosaur, or this bone belongs to a fish, or this bone belongs to a human. So what he's doing, he's finding the hidden features in this data. That is known as a unsupervised learning. I'll take another example. Let's say astronomer finds a new planet in the ecosystem or in the solar system. So new planet is there in the solar system. How will you figure it out what planet it is? It is he's going to find the hidden features, hidden information, like what is the distance from the earth, what is the distance from the sun, how much time it is taking to rotate on its own axis, or how much time it is going to take to revolve around its own axis. He's going to figure it out all these matrices, and then he's going to compare with the historical data of other planets and compare it and say this planet is more likely towards Mars. So in unsupervised learning, we never get the accuracies. We get the likelihood. We get the percentage of likelihood. Okay, this data belongs to this cluster. Or the bone belongs to a human cluster. But the archaeologist is not 100% sure. He say we are 90% sure that this bone belongs to a human cluster. If I'll give you some numbers, let's say 1, 2, 5, 10, 20, and if I'll ask you to classify it, how will you do? You'll find out the even and odd numbers, make two clusters. You'll find a prime and non-prime numbers, make two clusters. You find the numbers which are divisible by 5 and non-divisible by 5 and create two clusters. So everybody is going to create a different clusters, but there is an algorithm called k-means clustering, which gives you the same result. So these numbers can be weight of a person. These numbers can be the kilometer driven by the person. So hardly matters. In unsupervised learning, we don't need to know the data completely. System is automatically going to find the hidden features over there and find the mapping between these variables and figure it out how they are closely related to each other and create clusters. So in k-means clustering, we get 2 clusters, 3 clusters depending on the value we give. And that is one of the drawback of k-means clustering, because we don't know how many clusters are possible, but we need to manually say these are the clusters which has to be created, 2 cluster or 3. So even if some outlier is going to be there, it is going to be a part of one cluster. Like another example of unsupervised learning is if I suppose give you a banking domain data having credit and debit transaction of hundreds of customers, and I want to find out to whom I can offer a credit card. So obviously you will give a credit card to the people who have a high spending and high earning rather than low spending and low earning. So you can cluster it, the whole data, into two different clusters depending on the debit and credit transactions, and say we are going to offer the credit card to the people having high spending and high earning. So these are a few examples of unsupervised learning. So in unsupervised learning, we need to cluster the same type of things together, like all the birds together, all the monsters together, all the rabbits or herbivorous animals together. So unsupervised learning examples and the use cases if you want to see. So one of the example is party in a house. So that's a very good example. Let's say there's a party in the house and the lights are closed and some singer is singing. The singer who is singing, you can recognize the name of a singer. You can identify the name of a singer by hearing the voice. So what you are doing, you don't know the data, you don't know who is singing, but still you can recognize, you can find out who is singing by hearing the voice. You can come to know name of a singer, and that's one of the examples of unsupervised learning where you do not know the data but you find the hidden insights into it. Suppose a football match. In a football match, suppose you are new to the football match, you don't know like the football match completely. So what you'll do as a kid, some kid is going to watch a football match, he's going to identify the match players by their t-shirts or the dress code they are having. So different countries are having different dress codes. So we identify the country by the color codes rather than by the name of a player. Maybe you are not aware of all the name of the players, but you can identify which player is playing, which country player is playing. Similarly, recommendation system is one of the very good examples where you are giving some kind of a recommendation to the end customers depending on the content, depending on the user ratings, or depending on the collaborative filtering. So there are three types of recommendation engines. So if I'll talk about recommendation engines, there are basically three types of recommendation engines. One is called recommendation engines. One is called content-based filtering. Another is known as user-based filtering. And third is known as collaborative filtering. I'll just give you a brief idea. Content-based filtering is, suppose you go to the Amazon site and you say, I want washing machine or I want a mobile phone having 1 GB of disk, 500 MB of RAM, blue in color, and having weight of 20 grams. What you're giving, you are giving specifications what you want, and system is giving you some recommendation, and that is known as a content-based filtering, where you are giving specifications to the machine. What do you want? Now, what are the drawbacks of this content-based filtering? One of the drawbacks is that suppose you do not specify all the contents. Suppose you get the mobile phone, what you asked for, but once the mobile phone comes to you, find the Android version is not latest. So you may miss some specification and you end up with a wrong product. That is the drawback of content-based filtering. Another is user-based filtering, where system is recommending based on ratings what users have given. Suppose I want to buy a washing machine and I don't know which washing machine to buy. I'll go to Amazon, I'll just see the ratings of all the washing machine, and I'll pick up the one which is the best one or best rating ones. Now, what is the drawback in this? Maybe your taste is different as compared to the other person. Maybe your taste is like for you, maybe a WagonR car or a Maruti brand is not good, but for other person, it is the best brand. So it depends on the liking of a person. Maybe Maruti car has got 1 million ratings, good ratings, and Mercedes has got 500 ratings. But if you go by 1 million ratings, maybe you are a person who is of category who likes Mercedes and definitely will never like Maruti car. So it depends on the taste of a person, what exactly you like. So maybe the washing machine you buy by the recommendation of people, you may not like it because it is making a lot of sound to you and you want a machine which is soundproof. So it is basically dependent on the ratings what users are giving. Another drawback is that suppose a new product is launched. Suppose you launch a new company of mobile phone. Obviously, your product will not come there because the ratings are not there. Ratings are very negligible. It will not come in the listing. So that's a drawback of user-based filtering. Another example is collaborative filtering, where we search by content and then view ratings. So this we always do. We search, we know some parts of the contents what we want, and then we search the ratings, the best ratings, and then we order the product. And again, you may end up with wrong product. Why? I'll give you my real-time example. I bought this laptop around 6 months back, and it's having 1 TB of disk, and it has got 8 GB of RAM. And I bought this laptop by giving specification. My budget was 40,000 bucks. So I gave it in Amazon. I want minimum, maximum budget as 40,000. I want minimum 1 TB of disk, i5 core processor, Intel processor, and 8 GB of RAM. There was only one product listed out there, and only one rating was given. That is the best rating, 5 out of 5. I bought that laptop instantly, and when it got delivered to me, I installed Windows in it because I did not buy the pre-installed Windows. And once the Windows got installed, I started using it. After 1 month, I played a movie on this laptop, and I could not hear any voice. So I was surprised why I'm not able to hear the voice. So I thought there's driver problems. I updated all the drivers, but still could not solve the problem. I uninstalled Windows, installed it again, and again the problem persists. Then I called the customer care of Lenovo and asked them what is the reason behind it. They told me that this laptop has got monochrome speakers. So I've never seen a laptop which is having monochrome speakers which requires the headphone to speak. And that was a problem which I faced. Even though I did a content-based filtering and the user-based filtering, but still I landed up in the wrong product. These recommendation engines are just recommending you based on some algorithm, but still the algorithms are not very mature to give you the specific answers for your specific taste-wise recommendations. So these are still growing industry. And this is also known as a market basket analysis. In real terms, it is also known as a market basket analysis. So recommendation is one of the popular examples of unsupervised learning. And few of the algorithms we use here is k-means, a priority algorithm, hierarchical clustering, k-nearest neighbors, and support vector machines. So these are all unsupervised learning algorithms. So these algorithms are inbuilt in Python. You don't have to reinvent the wheel. Third type of learning is the reinforcement learning, where the agent learns from the consequences of its action rather than being taught explicitly. So here we are not teaching or giving some data to the machine again and again. System is automatically learning from the data and making some mistakes in decision. From the past action, it is learning. For example, a manless car is moving on the road and every second it is taking some image. Suppose the manless car looks at the red light and it crosses it. That's a mistake. It meets an accident. Then we make a policy that, okay, it is met the accident, so you should never cross a red light. So as a programmer, you keep on learning from the data which is coming up again and again. So it's a continuous learning process. There's a famous Maslow's dog theory over here. So example is that, like, the Maslow was having a dog, he used to feed him daily. So one day he started ringing a bell and then give a food to a dog. He kept on doing the same thing for 10 days. He rings a bell, give a food to a dog. On the 11th day, what he observed, when he started ringing a bell, the dog starts salivating. Why? Because you have induced that. You made the dog learn that whenever the ring is there or the bell is there, the food is going to be there. So you train your dog by ringing a bell and giving a food, and on 11th day you ring a bell and do not give a food, dog starts salivating. That is reinforcement learning. You induce the learning slowly and gradually into the dog. And that is reinforcement learning. Manless car aerodynamics is one of the mature examples of this. You might have seen autopilot mode. Most of the flights are running. So they get matured after a long period of time by taking some decisions based on the flights which already took off, or flight was safe. It learned from there, and now the algorithms are there which is taking decisions on the multiple dimensions. Human cannot think on multiple dimensions, but these machines can do. So reinforcement learning, observe and use the policy. Policy means some rules that we give it to the algorithm, and based on that it is taking some decisions. And decision can be good or a bad. So this is a duck. If a system takes a decision by looking at the rabbit, it's a minus point, and system learns from it, and next time it is not going to make a mistake. So how system learns, we tell them as a programmers. So we are going to tell it this is a wrong answer which you are given. So learn that if you see any rabbit, you cannot classify it as a duck. So this example I have already taken in front of you. Like, before conditioning, dog was salivating looking at the food, but after ringing a bell, dog do not respond. But when you ring a bell and give a food continuously for 10 days, even after ringing a bell after 11th, on the 11th day, dog starts salivating. Now, what can you do with the machine learning? We can do a lot of things. We can take a market value of the house. We can check whether the mail is spam or not. Is there any fraud transaction? What house lies in what segment? All these questions can be answered with machine learning. So where we can use the categories to predict the data. Is the person a male or female? So we can solve the classification problems using machine learning. Is the mail spam or not spam? That we already discussed. So these all problems are classification problems, and we have a k-means algorithm or k-nearest neighbor algorithm or support vector machine which is helping us to solve these kind of problems. Anomaly detection can be done. Is there any fraud transactions or not? Looking at the outliers. Suppose there are transactions and you want to see whether the transaction was a fraud or not, you can actually check it using machine learning algorithms. Is if someone is trying to hack your network or not? These kind of answers can be given. You can have regression problems. Data itself is what is the market value of the house, or how the independent variables are related to dependent. By looking at the linear regression line, we can find out how many are outliers by finding the mean squared error. Is it going to be rain tomorrow? These kind of problems can be solved by regression analysis. Clustering algorithms, we have already seen which type of house lies in which segment, what type of customer buys this product. So these answers can be given by the clustering algorithms. So clustering use cases can be marketing, insurance, land use, and seismic studies. So we can have clustering problems related to marketing, insurance, which policy, marketing, like discovering the distinct group of customer databases, such customers who make a lot of long distance calls. Insurance, identify the groups of crop insurance policy holders with a high average claim rate, farmers crash crop, which is profitable or not. Land use, identification of the areas which use GIS database. Seismic studies, identify the probable areas where oil and gas exploration based on seismic data. So all this predictive analysis in any of the industries, we can use machine learning. We can classify the various documents based on the kind of document it is. We can classify the document based on the URLs, whether Modi or Trump is talking about. K-means clustering is identify the similarities between the data and cluster it based on the similarities. We can plot students in the area in a given blow. I need to specific locations to build a school in the area so that students don't have to travel much. So these kind of clustering problems can be easily solved. So if you want to open a new school, you want to see where to open a school. Obviously, we'll open a school where the students are quite high. So you can find the population density and look at the age groups of the people over there and ask machine to predict what is the area where I can open the school, and it's going to grow. So you identify the location which looks good to you and you give the answer. Now you can use reinforcement learning for finding some decisions. So deep learning is used for complex problems like image recognitions. So deep learning is a particular kind of machine learning that achieves greater power and flexibility by learning to represent the world as a nested hierarchy of concept of abstraction. So it creates internal neural networks finding the relation between the independent and dependent variables. So images are in multiple dimensions. So images are generally in the 3 dimension of pixels, red, blue, and green. So red, blue, green pixels are in different dimensions. So if you have a complex data structure having the multiple dimensions, we can use deep learning algorithms. So example of deep learning can be you train your machine that if you look at a square, it has got 4 sides, it is closed, it is perpendicular, it has equal sides. So we're going to train this to a machine, and machine is going to identify any image whether it's a square or not. That's a small example. Another example is to find out whether it's a cat or a dog. There are multiple layers and pass the data to it. There is some bias attached to it, and there is some value attached to it. And at every level, it is going to identify the image in a closer look. So we'll talk about this when we'll start looking at the course. There is a concept of forward tracing and backward tracing in deep learning. So once the output is not right, it goes in the backward in all the layers, and that is known as the neural nets, which is simulating the human brain. So what is the difference between machine learning and deep learning? We already discussed. Deep learning is machine learning. Deep learning is a subset of machine learning. So if you see how the data science techniques scale the amount of data, so amount of data in the older learning algorithms performance was very low, but if deep learning, the performance becomes very high. So accuracies of the deep learning algorithms is pretty high, more than 95% generally, because they are very accurate algorithms in predictive analysis. So we can have a strong devices like Titan Z or other kind of devices which are going to be a really strong devices in terms of GeoForce GTX hardware dependency. So machine learning versus deep learning is dependent on hardware dependencies because deep learning algorithms take a lot of computational cost in execution. So deep learning algorithms, if you feed in 1 million records, it takes a lot of time to execute. So still the research is going on in the deep learning field where the algorithms are becoming more powerful. So this is an example of a deep learning where we supply the images to a layers, and different layers are going to find out different features. So first layer is going to find out the contrast, second layer is finding out the face, third layer is again finding out something, and at every layer it is solving the problem and finding the correct image what you're looking for. So deep learning application is in the manless car. It is going to identify what type of vehicle it is running and taking some decisions based on this. So problem solving approach is there in the deep learning, and if you combine it with reinforcement learning, it becomes more powerful. Now it's a time for execution. You need to decide where you want to land up your career. So if you really choose data science with Python right now, even though you are having from different domains, definitely it is going to be a value add in your career. So let me give you some time to ask questions. So I'll address few questions. It's already 10 minutes are there with me. So you can raise your hand, ask questions to me. So before asking questions, I just want a small feedback from you. How did you find today's class, guys? So just a small feedback from you. How did you like the today's class? And I hope I have given what best I can give in 2 hours about the introduction to machine learning and deep learning. Yeah, Vinayak, we can create our own library in Python. We can create all the py files are basically libraries. They are just libraries. You can call those files in some other files. Libraries are nothing but .py extension files. So Rakesh, in agriculture, people are not many times using it. So you can use in agriculture, like for a particular fertilizer, what is the crop yield? And you take this historical data for the last 20 years and predict this fertilizer is actually useful for a particular crop or not by looking at the historical data. No, you cannot duplicate any libraries in Python. Suresh, suppose sklearn library is there or pandas library is there. You cannot name a file with the same name. So chatbot Karan is again a machine learning implementation. System is finding out from the database what exactly the query you are asking, looking at the context behind it. It's a part of natural language processing. Vinayak, with Java, machine learning is not possible. Harsh, we can use Django framework to develop the website. So the best future of this Aarti is that if you learn machine learning with data science, every company is working for predictive analysis to improve their sales, to improve their presence in the market, and every company wants to predict with accuracy to get best decisions. So Bhaskar specialization, if you look for machine learning to perform well on cloud, or there are any special courses machine learning that built intentionally for cloud. So you have to learn machine learning for AWS. There is a Boto 3 library, Bhaskar, which is used for machine learning on the cloud. Now, machine learning, Anupriya, is totally practical. It's nothing theoretical. It's totally practical. You play around with the data, you get the results, you get the statistics, and decide on this. So, big data, Rakesh, is a Hadoop technology. Machine learning is implemented on the Hadoop. So, big data is the ecosystem. Machine learning is all about predictive analysis. So, Sad, for Java webinar, you need to write down a mail to Cognixia. The backend team will tell you when is the Java webinar. So, Durgesh, for getting job in the machine learning, you need to learn Python first, and then you need to have expertise on the statistics, because machine learning is all about statistics. Yeah, Shri, Django is far better than Flask. So we can implement Flask using Django. Yeah, Karthik, we can have a new websites like Python, like Netflix with Python, definitely. So the famous website is Trivago. And if you see Trivago, the Trivago website is made in Python itself. So Monica has asked a very good question, how to decide which algorithm to use. It depends on the data actually and comes with the experience. So you decide on the algorithm depending on your experience and the model that you are using. It comes with experience. When you learn data science with Python and machine learning, you'll see different types of algorithms based on different kind of data. No, Shiny and Django works in a different manner, Devender. Yeah, you can connect WordPress with Django. You can connect means you can have a two-way communication using Django. If you want to just connect and web scrap that web page, then Rajesh, then Harsh, you have to use libraries like Beautiful Soup or Request or Scrappy for web scrapping. How to find our best program course, especially if you are very new to machine learning. So if you're new to machine learning, take a consolidated course which is going to talk about Python first and then machine learning and then deep learning. So Cognitia course is having all these modules. So Dr. Lab, you are retired from government telecom. I want to explain the benefit of data science. Then you need to learn programming language first, Dr. Lab. You need to first learn Python, and then you have to take a deep dive into statistics, and then you can have a good career in data science. So if you want to start your career in machine learning, again, I'm saying the same answer. You need to learn Python first and then learn statistics, and then you can become a data scientist. So there is a website called sanfoundry.com, and if you go to that website, there are thousands of multiple choice questions given for Python. I'll just repeat the name, sanfoundry.com, sanfoundry.com. If you go there, you'll see thousands of questions of Python MCQs are given. No, Venkatesh, without statistics, you'll not understand machine learning. Machine learning is all about stats. You need to be really good in that. Krishna, if you're running DNN in your laptop, which is going to take 1 million records, imagine a lot of time, maybe 2 hours to 3 hours. Yeah, Karthik, we can do all those things what you're saying, like hacking or live surgery, or so that is a part of robotics, more of that. Machine learning is all about predictive analysis. So I think you can learn stats from a book called SC Gupta and VK Kapoor from Delhi University and Sultan Chand and Sons publication. There is a book of Python called SC Gupta and VK Kapoor. I'll just write down the name. And VK Kapoor. Fundamentals of Statistics. The name of the book is Fundamentals of Statistics. So Pragan, go to the Cognixia website or call the support team number, or you can drop a mail at support@cognixia.com. You'll get to know the details of the course. Yeah, there's a many websites from where you can get the data. There's something called UCLI website where you get the data set directly. We want to practice on some data sets. Can you give me more use case of machine learning in finance domain? So in finance domain, predictive analysis is done for the stock price. How much is going to be the stock price in the coming times? These kind of examples you can take. Yeah, you'll get the recorded videos on your email. UCLI. The website name is UCLI. Okay, guys. So thanks for your time. And if you have any queries and concerns, you can talk to the backend team. They are going to definitely help you out. And if you can visit the Cognixia website and you'll see the support numbers, you can get back to them and have more details about the course curriculum, what is the cost of it, how much it is time you are going to take, how much time taking that course is, all these things, you can easily get it from there. So let me close for the day. I would be happy if you just give the feedback after this. You'll get an automatic link, automatic web page is going to open, and you can send your feedback over there. Thanks for your time, guys. Have a great day. Bye bye and take care.